Hello everyone, I am Professor Vishal, working as an assistant professor in Arts, Commerce and Science College, Mumbai. Today we are discussing on the topic function of several variables in the curriculum of B.Sc of Mumbai University curriculum. So we are discussing about today for the functions of several variables. We are discussing about this, the function of several variables. So in order to discuss what is meant by the function of several variables, firstly we must know what is the function. What is function? The function defined from A to B is a rule that assigns every value of A to a unique value of B, to a unique value of A. For example, f of x is equal to suppose x square defined from R to R. F of x is equal to x square defined from R to R. This is one kind of function. Similar, if I am replacing this set A and this set B to some particular sets defined in two dimensions. Now what is mean by the two-dimensional set or two-dimensional? If we have this R, then this is called a single dimension, single line. Okay. Now if I have a cross like this, then this is what R2. Here we are, if suppose I am considering this point. Now it has coordinate x and y. This is what R2. And if I am going to define the function from R2 to R2, by the same rule, for every value of A, it has a unique value in this set R2. Then this is called a function of several variables. Likewise, if I am going to define the function from Rn to Rn, then this is called a function of several variables. Here n and m vary from 1 to and so on, m also vary from 1 to and so. So this is called a function of several variables. What is function of several variables? For every ordered pair of this set, there exists a unique ordered pair in this set. Then this is called a function of several variables. This is called a function of several variables. For example, what are the examples? If I am going to define this function f of x comma y equal to suppose x square plus y square upon x square minus y square. This is when x square minus y square is not equal to 0 and this is equal to 0. So this is what? It is a unique real number. So this function is defined from R2 to R. It is two-dimensional real valued function because the resultant whatever we get, it is a real number. So this is two-dimensional real valued function. Okay? This is two-dimensional real valued function. Now we are going to define some particular cases because in the curriculum we have the function f defined from R2 to R, R3 to R. So far we are going to discussing these two functions, f from defined from R2 to R, R3 to R. Again we are going to define R to R3, okay, R to R3, R2 to R3. So these are the some particular cases which we are going to deal with these kind of function of several variables, okay. So let us take some example of function of several variables. Suppose the function defined from R2 to R by f of x comma y is equal to f of x comma y is equal to 4x minus 3y divided by x plus y plus 5. Here, this is a real number. If I am going to substitute x and y by some particular real number, suppose I put here ordered pair x comma y is equal to suppose 1 comma 2, then this is a real number. So every time you get a real number. So this is a function of real valued function of two variables. How many variables are there? Two variables. So this is an example of real valued function of two variables. Real valued function of two variables. Next example. F of x comma y is equal to x square minus 2y divided by x square plus y square. X square plus y square. xy plus 5. Next example. F of x comma y is equal to x into y plus 5 divided by 2x plus 3y. Next example. F of x comma y is equal to 2x plus y square divided by 3xy divided by 3xy. So these are some particular examples of function of real valued function of two variables. Similarly, we will define the function of three variables also. That is defined from R3 to R by some particular examples. F of x, y, z. Here, how many variables are there? Three variables. But again, we get a product. This is a real number. So, this is a real valued function of three variables. This is a real valued function of three variables. Next, we will define the function f of x, y, z is equal to z cube minus x square y square. Similarly, we will define f of x, y, z is equal to square root of x square plus y square plus z square. F of x, y, z is equal to 1 upon x, y, z plus x positive, y positive and z positive. So these are some examples of the function of here three variables. Here these are some examples of the functions of two variables. Okay. So with this we will further move to the limits of the function of several variables. We will move to the limits of the function of several variables. In order to discuss the limits of the function of several variables, we must know what is meant by the inner product, what is meant by the norm. So with the help of norm and inner product, we will define the limits of the function of several variables. So what is mean? Firstly, we will discuss about what is meant by the limit. Firstly, we will discuss about what is meant by the limit. Limits of function of several variables. So what is meant by the limit? We will say that limit, suppose the term limit x tends to a, f of x. So what it means? It means that x approaches to a but not equal to a. So how close x approaches to a? Whatever you can, you will approaches to a. This means what is the difference between x and a? So you can make the difference as small as you can. It means that suppose x tends to 1. So is it x equal to 1? No. X is not equal to 1. So x minus 1 is not equal to 0. But x tends to 1 from left side and right side. X may be 0.99999 infinite. 1.0000001. It may be 1.0000001 from left side, from right side, because here is 1. So if we are going to approach x from this side, this is what 0.999, but from here we have 1.0001 sometimes, 1.00001 sometimes. So here x not equal to 1, but x approaches to 1 from either from left side or from right side. So this is what the meaning of the limit. So limit of the function of several variables is more same procedure. By the function of single variable, we have the limit x comma y tends to a fixed ordered pair. So fixed ordered pair f of x comma y is equal to n. When we say that this is going to happen? When we say that this is going to happen, if a comma b belongs to d bar. Now what is mean by this? In the previous lecture we had discussed about the domain, and d bar is what? Closure of this set. Either this is the member of this or the limit point of this set D. Either the member of the set D or limit point of this set D. Then for given epsilon greater than 0, there exists delta greater than 0 such that norm of the ordered pair x comma y minus the ordered pair a comma b is less than delta. Whenever this is less than delta, we have mod of f of x comma y minus epsilon minus l is less than epsilon. So here nothing but the difference. Whenever the difference between these 2 points can be made as small as we please, then this distance going to smaller and smaller. Okay, whenever this distance is small, ultimately we have the distance between these 2 numbers is small. Then we say that this limit going to be high. Whenever, what is the difference? When we make the difference between these 2 numbers is lesser, what is mean by? What it means? It means that these 2 points are approaches to each other. Then only the distance becomes smaller and smaller. So what is mean by the limit? Limit is nothing but if for given epsilon greater than 0, there is delta greater than 0. Whenever this distance is less than delta, implies that f of x comma y minus l is less than epsilon. Then we say that limit x comma y ab f of x comma y is equal to n. So this is the function of what? Several variables. This is what the function of limit of the function of several variables. Now we will discuss about some examples of the function of several variables. We will discuss about the limit of the function of several variables. Likewise, we will define the function of 3 variables also. So some point we have to consider for finding the limits of the function of several variables, that the point which point a comma b must be interior or boundary. That is roughly we can say that it must be the limit point of this set. Second one, no need to know the value of f of x comma y at a comma b. It is not necessary to know that what we know that to know that the value of f of x comma y at a comma b. It is not necessary to know that the value of function at a comma b. We have to find the value at x comma y tends to a comma b. Limit x comma y tends to a comma b of the function f of x comma y. It means that what it means? It means that x tends to A and y tends to B. But x is not equal to A and y is not equal to B. What it means? It means that x minus A is not equal to 0 and y minus B is also not equal to 0. This term x comma, again further we will discussing about simultaneous limit and iterated limit. So simultaneous limit, it means that both the terms simultaneously tends to A comma B. In both the cases, if limit exists, then both they are equal. So for example, if we consider limit x comma y tends to A comma B of the function x is equal to what? Limit x comma y tends to A comma B of the function y is equal to what? Limit, so this is suppose A, B and C. Limit x comma y tends to A comma B of the constant function is equal to what? So here x tends to what? A, y tends to what? B. Now substitute here x equal to A, we get this value. Limit here we get B. And here no values are x and y, so this function is independent on this variable, so this is constant function. It means that it has value as it is c. So these are the values of these functions. So with the help of these properties, we will evaluate the limit of some function of several variables. Consider the first example. Limit, evaluate limit x comma y tends to, first example, limit x comma y tends to 1 comma 2 4x minus 3y divided by 4x minus by x plus y plus 5. So consider L is equal to limit x comma y tends to 1 comma 2 4x minus 3y divided by x plus y plus 5 is equal. Now if I had substitute here x y tends to 1 comma 2, it means that x tends to 1 and y tends to 2. So substitute here x equal to 1 and y equal to 2, we get 4 into 1 minus 3 into 2 divided by 1 plus 2 plus 5, which is equal to 4 minus 6 divided by 8 minus 2y 8, which is equal to minus 1 by 4. This is simply the limit of this function at this point 1 comma 2. So very easy to find the limit of these functions of several variables. Next example. Limit x comma y tends to minus 1 comma 1 x square minus 2y divided by x square plus y square, x square plus y square. We have to evaluate the limit of this function at this point 1 comma minus 1. We have L is equal to limit x comma y tends to minus 1 comma 1. What is the function? This is the function x square minus 2y divided by x square plus y square, which is equal to minus 1 square minus 2 into 1, because x tends to minus 1 and y tends to 1. Minus 1 square plus 1 square, we get 1 minus 2 divided by 1 plus 1, which is equal to minus 1 by 2. This is the simply limit of the given function at this point minus 1 comma 1. Again in the notes I will give you some more examples, solved examples. Also I will give you some practice example. Next, consider the example. Third one, evaluate limit x comma y tends to 3 comma 3 of the function x square plus xy minus 2y square, x square plus xy minus 2y square divided by x square minus y square, x square minus y square. Okay, this is the function of two variables. This is the function, real value function of two variables, and we have to evaluate limit of this. We have L is equal to limit x comma y tends to 3 comma 3 of the function x square plus xy minus 2y square divided by x square minus y square. Okay, now which is equal to limit x comma y tends to 3 comma 2. Here we have to just, if I am going to substitute this 3 and 3 at this point, then we get 9 minus 9, which is 0, which is not defined. So further we have to make some calculations, some simplifications in this function. So we will just factorize this term, numerator, we get x square minus xy plus 2xy minus 2y square divided by x square minus y square, which is equal to limit x comma y tends to 3 comma 3. We get what we get, x square. So just take common x from this, we get x minus y. Here just take 2y common plus 2y, we get x minus y divided by x square minus b square is what, a plus b, a minus b. Using this expansion we get x minus y, x plus y. Is equal to limit x comma y tends to 3 comma 3 x minus y, x plus 2y divided by x minus y, x plus, so this x minus y get cancelled because what? This is non-zero term. Limit x comma y tends to 3 comma 3, we get x plus 2y divided by x plus y. By substituting the limit we get 3 plus 2 into 3 divided by 3 plus 3, we get 3 plus 6 divided by 6, that is 9 by 6, that is 3 by 2. This is what the limit, this is what the limit of this function x comma y tends to 3 comma 3. So this is what 3 by 2 is the limit of this function at this point 3 comma 3. With this, in this video, so far we have discussed about the limit of the function of, the definition of the function of several variables, some examples of the function of several variables, definition of the limit of function of several variables, and some related examples to that. So in the next video we were discussing about the sandwich theorem. algebra of the limit of the function of several variables, and some related examples to the sandwich theorem. So in the next video we are discussing on that. Thank you.